Okay, you guys, so let's go ahead and do another one. This is a distance time chart, so we'll have a distance time graph. But let's go ahead and first clear the data from our last problem. So we'll make way for this new one. So again, we'll just go to y equals, clear out, and go to your list, right? Oops, stat, and edit your list. Arrow up to highlight L2, press clear and enter. Arrow over, highlight the L1 by pressing up, press clear and enter, and you've cleared out the data. So we're ready for our new data. So our new data in our x coordinate, we have 10, enter, we have 15, enter, 25, 40, 75, 90, and 100. Okay, and already the likelihood that this may be a line might be in jeopardy, because notice that the change in x, we go from 5 to 10 to 15, 35, right, 15, and then 10. So the change in x is all over the place. So it's kind of hard to realize if this is the line or not. Going to the L2, right, our y values, we have 70, enter, 100, enter, 90, enter, 115, and we'll enter, 140, and we'll enter, 175, and enter, and 200. All my data matches up, right? The number of x values matches the number of y values, and everything looks good. So now what we want to do is go plot the data. Again, taking a look at the window, before I even go there, notice that the x values go from 0 to 100. So how about I let x-min go from -10, that way we see a little bit of the y-axis, and let's go out to 125. And we'll go in steps of, let's just say, 10. Alright, so there's our x thing. For the y, we go from 70 and top out at 200. So how about, again, I want to see a little bit of the x-axis, so we'll go -10, and how about we go to 225. And this time we'll go in steps of 25. Okay, and so when I go, make sure my stat plot is on, so second stat plot, plot 1 is definitely on. It's showing me a scatter plot, L1 and L2 and that. So when I press graph, there's my data. Okay, so for this table, there's the data. Of course, we weren't expecting it to be a line, and it doesn't look like a line. But it, with some varying points, it's behaving almost linearly. So, linearly, I would probably say almost. So we should be able to find a linear model. Well, first let's go do this by hand. Again, because the data is all over the place, mine isn't going to be great. So I think, how about I just pick the first and the last point to kind of just give us a generalization. So I'm going to use 10 and 70 and 100 and 200. So I want f of x equals mx plus b. I don't have a y-intercept available, so we're definitely going to have to use our point slope model first. Finding the slope, we're going to take 200 minus 70 and divide that by 100 minus 10. I believe that gives us 130 over 90, which is 13 over 9. So how about I use this data point here? So we got y minus 70 equals 13 over 9, x minus 10. And so there's basically our point slope model. To get it in this form, we got to solve for y. So I'll first distribute that 13 over 9. 13 over 9 times 10 over 1 is 130 over 9. I add 70 to this, right? And again, I need a 9 over 9. So we get y equals 13 9's x. 0, that's 630 over 9. So 630 minus 130 over 9, that's going to be 500. Okay, and so there's basically my model, 13 over 9x plus 500 over 9. And so when I go to my y equals, let me get that glare out of there again. My y equals, I like parentheses, so I got parentheses 13 divided by 9, close parentheses times x, plus 500 divided by 9. And so when I go graph that, right, you'll notice that it is a perfect fit for the two data points that I used. As a matter of fact, it looks like a pretty decent fit for that one as well. So there's my data. It looks solid. We're good to go. All right, so there's that guy. What about the regression line? Well, again, what we'll do there to find the regression analysis line is I'll press stat. I want it to calculate. I want it to do a linear regression. I want L1 to be the X list. I want L2 to be the Y list. We'll pass that, and then I would like the calculator automatically store the regression equation. So we need to get to the F4. So alpha F4, and let's store it in Y2. Arrow down, press calculate, and there it is. So it's a more complicated one. So the calculator model is, how about we say 1.2288x plus 64.822, actually it'll be 30 if we round it 4 decimals. So there's the calculator model. Alrighty, so now let's go ahead and graph it. And so when I go graph that, we'll go to y equals. There's my model, and there's basically their model. So when I go graph the two together, there's the data set, and there's my line. I'm trying to get that glare from the, and there's their line. And you can kind of see that it's somewhat of a better fit, all right, than what I have. It sits a little bit above it, comes a little bit below it, right? But it's generally, closer to all the data than mine was. Okay? So how about, why don't we do this? I'm going to go ahead and just turn mine off. All right? So you just do that by highlighting that equal sign, and it's now off. So when I go graph it, the only thing you see is the regression line. So it actually fits one perfect, but it's much closer all the way around to the others. So I'm not going to bother with my model. Let's use the regression model, predict the time, right? Predict the value. I guess this should have been the distance. What's the distance when we've gone 120 seconds, right? What's that going to be? Well, I'll go to this guy here. I think my window's large enough. We went to 125, yeah. So we'll go to y equals, graph. We'll go to calculate, second calculate. We want a value, and I want to put 120 in for x. And so the cursor's up there, and it looks like what it's giving us is 212.28411. All right, so at 120 seconds, the distance that we've traveled according to the regression model is 212. Okay, so there you have it. Last but not least, let me wrap this up. What is the meaning of the slope, right? So our slope is 1.2888 for that. And if you go back, remember what slope is. It's the change in distance this time, right? My y value over the change in time. And the distance is measured in meters, and the time is measured in seconds. So this is meters per second. So this is basically telling us that on average, over the interval from 10 to 100, right, overall, this person is traveling at about 1.2288 meters per second. Okay, so I guess maybe that's what, a very brisk walk possibly, right? Or maybe even a very light jog. Okay, so there you guys have it. All right, there's how to press the buttons, how to enter data, how to do regression analysis, and so hopefully that arms you to do some things out in the real world. Although I think we end up using Excel spreadsheets, but you can use at least your TI calculator and know what's happening there. That wraps that up. If you have questions, you better ask me on Canvas, or you guys can also ask me at an office hour if you set up an appointment. And one last thing, there's not really a quiz for this section since it's really just a bunch of button pressing. I'm going to treat this like we did the graphing calculator module. There is an assignment, so consider it your homework. And when you turn that homework in on time, I think the due date is October 12th. What I'll do is take that score out of 25 and use it to replace one of your lowest quiz scores. So you have 2 chances to replace low quiz scores, so especially those who got zeros. So get the graphing calculator done. Hopefully you got that done, and then you can get this one done and replace a low score somewhere. Okay, so not an official quiz for 4.2. It's an assignment that you do as homework. Turn it in, I'll grade it and give you a score out of 25 and replace your second lowest quiz score of the year. See you guys there.